So in the unit that we've been discussing graphs, we've been discussing functions and plotting functions. What we're talking about in section 5 is what we refer to as scatter plots. Scatter plots are basically graphs where the points are just showing a relationship between data. It's kind of like the type of information that you would get where it's not a constant change, it's just scattered everywhere. So, for example, a situation such as this could be the points that you earned by throwing the darts. And it depended on the amount of time that you were playing. So if you were just throwing randomly the darts, maybe after 1 hour, you have accumulated this many points. Let's call it 20 points. Then hour 2, you accumulated this many, and you keep going, and it's just all over the place. It's not a constant rate. You notice that it's not a consistent line that is perfect. What happens with trend lines or scatter plots is just a whole bunch of stuff that was just thrown out there to gather information. And we're going to cover a little bit more about this in a little while. So if you were to look at the the scatter plot, which is basically a whole bunch of data just thrown out there, you would notice that on average, like if you were to draw what we call a trend line, and the trend line is a line that would sort of summarize all of the data. So maybe something like this. The one for the second one would be something like that. The third one, there's no line that you can connect to summarize all of it all together. If it is going from left to right, upwards, that is what we call a positive correlation. It's going upwards. If it is going subsequently downwards from left to right, it is called negative correlation. And if there's really no relationship whatsoever within the points, they're just all over the place erratic, then there's no correlation. So scatter plots are basically graph where there's lots of points. You can talk about positive or negative correlation or no correlation. Let's take, for example, this problem that they give us here. So the table right here shows the number of cookies in a jar from the time since they were baked. And if you look at the number of cookies that were in the jar, you would notice that after the first day, after day 1, there were 24 cookies. So let's count. If we're counting from 24, 16, 10, 7, we can count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So after day 1, there was 24 cookies. At day 2, there were 16 cookies, which is right here. Actually, it's right up there. So 2 is 16. Day 3, there was 10. Day 4, there were 7. It's not a perfectly straight line, but you can see that based on the data, this amount of data, if we were to create a trend line, just sort of to summarize it, it would look something like that. And it's going down from left to right, which means that this would be called a negative correlation. What this means is that as the number of days increased, the amount of cookies decrease. That is a negative correlation. When the independent variable increases and the dependent variable decreases, that is negative correlation. Same thing as if it had been. As we look at this example 2, they want us to describe the correlation. So we look at it, and remember, we see that it's just a whole bunch of scattered points everywhere. If you were to draw a trend line, and remember that the word trend line means kind of like a summary line. So if we were to draw a trend line, we would probably say that it would be something like this. Or maybe actually that one doesn't take as many, maybe something like this. So the trend line is demonstrating that from left to right, it's going up. So this means that this would be considered a positive correlation. Example 3 is asking us to identify the correlation you would expect to see between the given data set. So let's look at letter A. Average temperature in a city and the number of speeding tickets. Well, you really have to think about this. Do the number of speeding tickets have anything to do with temperature? Or does the temperature have anything to do with speeding tickets? There's really no correlation whatsoever. I mean, I guess if you really looked into it and you said, oh, the hotter that it is, the faster people want to get home. But if you take into account the fact that people have air conditioning, that's not going to happen. So in reality, when you're looking at this type of thing, where you're trying to see the relationship between two completely irrelevant things with one another, it's called no correlation. Let's look at letter B. The number of people in the audience and ticket sales. In this case, you would notice that if you think about it rationally, the more people that there are in the audience, the more there's ticket sales. So that means this is a positive correlation. The next one, a runner's time and the distance to the finish line. So what this is saying, when it says the runner's time, it means how long they've been running. So the longer they've been running, the less the distance to the finish line is. This would be called a negative correlation. Example 4. Choose a scatter plot that best represents the relationship between the age of a car and amount of money spent each year on repairs. Interestingly enough, if you think about the fact that the older the car is, the less reliable it is, which means that the older the car is, the older the car, the bigger the age. As age increases, the more you're going to have to spend on repairs. So that's a positive correlation. So as we look at here, this could be 1. This could be 1 because they're both kind of going up. Graph C is definitely not 1. Now when we look at these two here, ask yourselves what the difference is. This graph, graph A, is showing you negative age. You can't have negative age. That's what we call not at all relevant. So obviously it would end up with this one. Graph B. As time passes, you are going to, for the most part, have to be spending more money on your car repair. Okay, let's look at example 5, the final one, before you guys have to work on your independent practice. The scatter plot shows a relationship between the total amount of money collected at the concession stand and the total number of tickets sold at a movie theater. Based on this relationship, predict how much money will be collected at the concession stand when 150 tickets have been sold. So if we think about this, those dots represented the scatter plot. That line that you see there is the trend line that has been drawn to create some sort of a relationship. It has the same number of points above it as it does below it. That is the trick of drawing a trend line. And they want to know, to predict how much money will be collected at the concession stand. So this is actually what they're asking us. Predict how much money will be collected at 150 tickets. Well, if we look at our little graph, this is 100 tickets, this is 140, it looks like they're counting by 40, so maybe 20, so 60, 80, 100. Looks like they're counting by 20s. So if this is 140, this is going to be 160. That means that 150 would be right about here if this is 160. And if we go up, it's going to be right about here. And that right there, okay, so let's do it again. 160, 150 is probably between. That's going to be right about here. Here it looks like they are counting by 100s, 200s, 300, 400, and so on. So 150 is going to be, if this is counting by 100, 1, 2, 3, 4, 5, 6, this is 700, that's 800, that's about 750. So the prediction is that if you sell, or if 150 tickets are sold, then you are going to have about $750 in concession sales. So that is what we refer to as trend line and making predictions on trend lines. Now you can go ahead and do your independent practice. Make sure that you are completing all of it and uploading it to Canvas so that I can make sure to see that you have completed it. And if you have any questions, please feel free to ask.